Hello, welcome to another topic of AI class. And today, in this video, I would like to talk about the K nearest neighbors, in short, KNN. So KNN is a little bit special, different from other models that we talked about previously, because it doesn't really require training at all. It just memorizes the training data sets, and then it gives you the answer based on what's in the memory. It's no training, no fitting. Okay. And another term for that is called lazy learning, because there's no learning at all. Okay. And the way that it works is quite simple, actually, to think about it. Okay. Right here. So uh, in the so basically you give the model the training data, and the illustration of that is right here. So you have three classes: the red, green, blue classes, and then in the two-dimensional attributes, I guess we have only two attributes, right? So first, you're gonna have to choose the number of neighbor. Okay, k. So what k mean is that if you have a sample in question, this guy right here. So this one is a sample that you don't know the class, you don't know the answers. You're gonna have to choose the number of neighbor that the model is going to consider. Okay, so let's say k equal to 5. Okay, so you want to choose 5 neighbors, right? You want to choose the 5 closest neighbor, so that's the nearest neighbor. Okay, so another thing you have to do is that to choose what is the distance matrix, right? So in here you just choose the Euclidean distance. That will be the most simple things you can do, right? So essentially the model will search for the 5 closest neighbor according to the Euclidean distance. So it's gonna be the 5 of this right here in the dotted circle. Okay, so find the k nearest neighbor, and then the model is gonna look at the type of neighbor, the class of your neighbor, and just assign the unknown sample with the majority vote. So that means that in this circle, there are the majority of the classes that you find from your neighbor is blue. So you are going to assign your sample in question with the blue class. So essentially, this is just a proximity, right? Assuming that you're supposed to be the same class as your neighbor. That's the essence. So it's pretty. I guess the way that it works is pretty simple, but it works pretty well too in a lot of cases. Okay. So first, I guess I mentioned again that you choose the number of k. So that's probably the most important things. Another thing that's also quite important is to how do you measure distance. And I guess the most intuitive for us, I guess the most common sense to us would be the Euclidean distance. So it's just the shortest space between 2 points if you look at it along the two-dimensional surface, or I guess multi-dimensional surface. Another way that you can do is Manhattan. So this one just go like horizontal and vertical. It's almost like a street in a block on along the streets. So Manhattan is like the city. So it's like a city blocks. Okay. Another one is Minkowski. So this one is the generalization of the Euclidean space into like hyperspace. So essentially it's like the p, but then it's square root of 1 over p. So this one is kind of hard to I guess visualize in multi-dimensional space. But essentially, the Minkowski can turn into Manhattan if p is equal to 1, and Minkowski can turn into Euclidean if p is equal to 2. So that is I guess the generalization of the distance matrix in multi-dimensional space. Okay. So what is the good and bad of KNN? So the first one is KNN doesn't require any training. So when you have new data coming in, actually it can use that data right away without having to retrain it. So it's pretty good, adaptive to new data. But the downside is that as you have more and more data, your memory is gonna grow. So that doesn't work well with like big data, right? And another thing is that there's something called curse of dimensionality, which means that as your number of dimension, so number of dimension is the number of attributes, right? Think about our iris flower. We only have 4 attributes. You can have, if you have 100 attributes, that means that you have 100 dimensional data. And once your data became more and more increased in dimensions, I guess the way that the distance matrix works in here, it tends to clutter things together. And then what happened is that it tends to be more and more difficult to classify in the high dimensional data. So what it means is that essentially results in the fact that KNN doesn't work very well once you have a lot of attributes. Okay. All right. So another thing that kind of work internally is the algorithm of finding the distance between neighbor pairs. There are many ways you can do brute force compute every distance between all neighbor points. There are quicker way called k-dimensional trees and ball trees. So this one is just the detail of how you come up with the like you decide on what is the nearest neighbor points, because the search algorithm for that can be quite time consuming. So you have a choice between computing everything and get the optimal one, or you choose the one that are faster but might have some limitation or something like that. So usually the default one, if I remember correctly, it's probably this one. I'm not sure. I'm not 100% sure, but probably ball trees like that. Okay. So let's apply that KNN to our iris data again and see if it works. And I just want to mention that this is the only algorithm that actually can obtain the accuracy of 100%. Okay. So stay tuned.